Assalamualaikum. Today I would like to give a talk about a study on journal paper. This journal is about a thermodynamic application, which is the effect on performance of residential air conditioning system using water condensate as subcooling. Air conditioning is one of the cooling system that use thermodynamic application, and we have studied this on chapter 6. The journal is specifically a study on how to reduce the power consumption of this aircon. Several methods have been investigated by researchers, such as using inverter to regulate the compressor speed, using ejector as an expansion device, and inserting nanoparticles in the compressor lubricant. Other than that, using condensate water to reduce the temperature of the discharge compressor is also a method to enhance the aircon performance. Okay, how is using condensate water to reduce the temperature of the discharge compressor can enhance the aircon performance? Technically, the temperature difference between condensate water and discharge compressor is high. As a result, there is the potential for condensate water to absorb heat from discharge compressor, because some part of heat has been absorbed by the condensate water, so that there will be subcooling on the condenser outlet. There is a same study use of condensate water was carried out by Ibrahim and the team. An air conditioning unit with cooling capacity of 1.5 ton refrigeration was utilized in their experiment. An evaporative cooler using condensate water was employed as pre-cooling the air temperature before entering to the condenser. They reported that the power consumption of compressor was decreased by 6.1%, whereas the COP was increased by 21.4%. However, there is difference between previous and current studies. This study will focus on using the condensate water to lower the temperature of the compressor discharge to increase the aircon performance.
Assalamualaikum. Hi, my name is Muhammad Nur Syafshami. I'm going to explain about the schematic diagram of this journal. Okay, this process begins from the compressor starts working, which is compressing the gases tightly to increase the pressure and the temperature of the gas vapor. Then this gas vapor will go to the condenser through the connecting pipe. In the condenser, the high pressure and the temperature gas vapor will change from gas to liquid in the same temperature. This means the temperature will remain the same, but the condenser will change the physical state from gases to liquid. After that, the high temperature condensed liquid refrigerant will leave the condenser and enters the expansion valve through the connecting pipe. Okay, at the expansion valve, the temperature of the liquid refrigerant coming from the condenser is cooling down, and it causes expansion, which will reduce the pressure between the refrigerant molecules, which will cool it down simultaneously. This means the expansion valve will despressurize the pressure of the refrigerant and cool it down, and also controls the amount of refrigerant or voltage flow entering the evaporator. Okay, now the low pressure cold liquid refrigerant enters the evaporators. At the evaporators, cold liquid refrigerant absorbs heat from the indoor air, and it starts to evaporate to form a vapor. Okay, as a result, the home environment loses heat and cools down. Lastly, hot gases refrigerant from absorbing heat again goes to the compressor, and the process is repeated continuously in closed loop.
Assalamualaikum. For this experimental investigation, there are two experiments that have been done to compare the performance of air conditioning. For the first experiment, the air conditioning is not using condensate water, which is only the normal type of air conditioning. The use of R410A as the working fluid was utilized in this experiment. Okay, so this is the example for R410A item. For the second experiment, it used the condensate water and heat exchanger to lower the discharge of the compressor and to generate the subcooling. Next, the use of condensate water will reduce the power consumption and increase the cooling capacity. By lowering the compressor discharge temperature using condensate water, it will reach subcooling on the condenser outlet because some of the refrigerants have been absorbed by condensate water before entering the condenser. The subcooling causes the increase in cooling capacity of the air conditioning. Lastly, there are 5 instruments are employed to measure those parameters, which is thermometer, pressure gauge, manometer, ammeter, and voltmeter.
Assalamualaikum. I will give an explanation related to the calculation on the selected article. Pressure, air velocity, electric current and voltage are measured from the test conducted. There are 2 different cases in this experiment with and without condensate water. The input power calculated by using the power equal to IV formula, which I stand for electric current and V for electrical potential. Power consumption are evaluated by using the calculated power times by time. The mass flow rate can be obtained using the multiplication result of density, velocity, and area of the ducting area. The COP, which is the coefficient of performance, is calculated based on Q over P formula, which the Q and P value are obtained before. The dissimilarity of condensate water existence and non-existence are calculated by 3 equations, which is input power reduction, cooling capacity, and COP improvement, which consists of the difference of existent and non-existent of condensate water value divided by condensate water value. For the result obtained, we can see that the temperature using condensate water is lower than without using condensate water by an average 7.6 Celsius. By having a lower discharge temperature, the power input are lower by 48 watt, which resulting to a 5.9% decrease compared to not using condensate water. By having lower discharge temperature also give a lower outlet temperature of condenser by averaging 2.7 Celsius. This then resulted into an increase of cooling capacity, for which condensate water having a 300 watt higher cooling capacity. All of this improvement by condensate water has resulted to an increase of COP by 16.4% compared to without using condensate water.
For improvement suggestion, a heat exchanger can be added to the liquid line to reduce the refrigerant temperature. One popular method is called suction to liquid line heat exchanger. Next is subcooling from liquid column. A column above the pump inlet changes the liquid refrigerant condition from saturated to subcool. This ensures that internal losses in the pump's inlet section don't generate vapor that can reduce pump performance. And last one is reducing direct environmental effect. A large part of environmental impact comes from permanent leaks and accidental release of refrigerants. Annual leak rates can reach 30% of the system charge, causing considerable direct impact.